In most cases, when you build your backend application or REST API, you need to connect to a source of database. This database could be relational database or NoSQL database, right? But in most cases, you need database. When you build your backend application using Ktor or any framework without a database, then you are probably building a middleware or a source of API gateway where you want to redirect requests from clients to different microservices, right? But in this video, I'll show you how we connect our Ktor backend to a database using a library, a lightweight library, expose, right? Then if you remember, when we started this playlist, we had a architecture we've been using, right? In this architecture, we divide our backend to different layers. We have the service layer, repository layer. Now, this will make sense because now that we want to connect to database, we have nothing to do with other layers other than repository layer, since repository layer connect directly or interact directly with the database, right? So expose, the library we're using, will be coming in between repository layer and database layer. So that is the point we need to work on, and this makes sense because in case you want to change your database in the future, you still have nothing to do. You don't have to modify the endpoint layer and the service layer. I hope we go straight to the official site of creating a Ktor application, though you can achieve this too in IntelliJ, but I prefer to use the official site so we can get the latest libraries and dependencies. So I'll go straight to create application. We have it this way. So the plugins we're going to be using, we'll need routing to handle our endpoint, right, and handle requests from client. Also, we're going to need content negotiation. This is to negotiate the content between client and server. For this, we are going to be working with a particular media type, which is JSON, right, between the client and the server, JSON. And as you can see here, we have different implementation of JSON, but we're going to stick to the first one, which is Kotlin X serialization, right? Then I'll add Postgres. I already have Postgres installed on my system, so I'm going to add this plugin. Then the expose, the library itself that we'll use to access our database. If we go through the documentation here, you can see that expose is a lightweight SQL library built on top of JDBC driver for Kotlin language, right? And this has two different approach. You can either use the type safe SQL wrapping DSL, or you connect using data access object. But I want to stick to the first approach because I want us to have the feel as if we are using the standard SQL. So I'll use type safe SQL wrapping DSL. So we'll add this to it, right? And if we go to the we'll still maintain the default configurations, right? Use the same build system we used earlier, which is Kotlin, Gradle Kotlin, the latest version. Then for the embedded container, we maintain Netty. I think this is fine. Then we don't need to include any sample code here because we are going to be working with our existing code just to connect our Ktor to the Postgres database. So I'll import this project, then we'll continue in IntelliJ. Now I have the source code imported to IntelliJ, right? Ktor API service expose, the library that we're going to be using to connect to our database. So I've copied the source code from our previous video, and the link to that video will be in the description box below in case you want to go through. I don't want us to start creating everything from scratch, right? Since we just want to connect our backend application in Ktor to Postgres. And initially we use an in-memory collection, which is map, but for now we want to connect to a real-time database. So before we get there, let's make sure our database is up and running by accessing our database from IntelliJ. So come here, we add a new data source this way, right? And we have Postgres here. Then we'll put in the credentials. For this, I've changed the port to 33 for the sake of this particular video. Then for user, I'm maintaining the default user. For password, I'll put in the password, right? From here, then the database name is Ktor exposed. So we can check our database where we'll make some insertion or when we insert user data. Then let's test the connection. All right, this is good. We've connected successfully. So we'll apply this, then connect. So we can access our database from IntelliJ. So we'll create a new table and continue from there. So let's go straight to this place. And for library, we've added two different libraries to the existing source code. We have Postgres, then we have expose. For expose, we added two, which is core and JDBC. These are the new libs. Now that our source code is set, right, so we'll just go straight, add a new package to handle our database. We'll call this package name database. right? Then we create a new object class, which is a singleton class in Kotlin to handle our connection to database. We have it at database, I'll call this database factory. This is a singleton class. Then I want a function here to initialize our database connection here, right? Then I'll call a database object class. You can see this coming from expose.sql, this particular one, to connect to our database. And mind you, the information we have here is just to have it on your source code. It doesn't mean that your application will remain connected to database. No, it is when expose want to connect to your database, then make use of the credentials we are going to have here. You can see that we can connect through different means or different approach. You can use the data source. Maybe you want to import a library like iCarry to manage your connection pool. But for this, I'm going to keep it simple. I'll use the first option here. And this option is taking a URL as a string, right? Then we're going to put, we need username. We also need password for this, right? And for URL, we are using JDBC. So we're using Postgres. It should be this way, Postgres SQL :/ with localhost port 533. The default for Postgres is actually 5432, but I've changed mine to 533, right? Then the database name is Ktor exposed, right? Then you need the username and password. Ideally, you don't want to manually or statically configure your username and password here, right? You need to, because you don't want to expose your username and password in case you want to push this to a repository. So it is better we use a system environment for this. And to add this to a system environment, I think we can close this, expand this. To add this to a system environment, we have it in IntelliJ, so that is possible. So you come here, you can see we have a DB user and password. We already have this here, so we'll just go to, and the name is DB user and DB password. So we'll come back to this place. I can have this as private value of DB user, right? We're getting this from this function system.get environment, and for this we have DB user. Duplicate this. We have for password here, password. We also have for password, right? So you can connect this to this and add this to this. You can see we have an error here. Yes, it's expecting string but found nullable string. So we can simply have enough safety here, enough safety code, though we are sure that the value is there. So we can easily return empty. So this is fine. The next thing we want to do now, any request you are making to your database, right, using expose, it has to be wrapped in a function which is transaction function. This transaction function, right? Good. And we'll make use of a utility function from expose, which is schema util. Yes, schema util. We use this to create our table, but we've not created any table. Let's come back here and create a new table. Let's create a new package and call this table. And for this, we're going to follow the syntax, which is creating an object. This will be user table, right? This should extend table coming from expose org.jbrains expose.sql. This particular table, you want to give it a name at this point, which is users, right? And for this, you want to define an ID. This should be varchar. The name should be ID. Then you want to have the length. Since we are using UUID, maybe we'll leave this as 100. You need first name, last name, then age. We have first name here, first name. Then we have first name here. We have last name. We have age. Age is integer. Integer, we don't need the length for this, right? Then this is age. This is last name. And this is first name, right? Good. So if we can leave this for 50, then this 50, we can then go to create our table. The table we're creating here is user table. Good. So we have the information here for expose to consume whenever you want to connect to database, but then our application class need to be aware of this. We can simply call our object from here, which is database factory dot init. Great. So we've provided our connection credentials to expose this, then we're good to go from here. Then if we go straight to repository, which is the particular function we want to modify here, initially we'll use a collection, which is a map. So we'll do away with this, then re-implement this. Let's implement all the old functions. Good. Now to get our users, we need to call a function, and we need to call an extension function on table user, and this is to select all. We're selecting all, no where condition, just select all. Then we can simply map this, because if you check, this is expecting user model, but this will return result row. So we need a new converter. We can add that to this, and this should just be a file. We'll have it as table converter to convert the row to model. Simply have a function here. We can have a row to model, right? And this will take in the row, which is this, and this is expected to return user model. All right, good. So we can simply return user model here, right? And this is expecting ID. The ID will get it from row, call user table dot ID, right? Duplicate this for first name, for last name, and for age. Then we have first name here, last name, good, age. This is an integer, so we have age here. We have last name here, then we have first name here. Good. So we have a mapper function here, which is just going to be, this is simple. We'll come back here. So we can simply map our IT row to model. Then we have IT here. Great. Then we can have this to return this. Good. But if you remember that when we try to create our table here, we needed to add this to a transaction function, right? So when you are accessing Postgres with expose, you are required to wrap this. So we need a wrapper function to wrap all our query when we are when we are accessing expose, accessing our database. So that wrapper function could be here. We're going to be having a wrapper function, right? And this first function is going to be query, right? We want this to be a generic type, because this is just going to wrap our query to transaction, then make it run in a different context, because connecting to database is a non-blocking process, right? So we want to use a different coroutine context to connect to our database. So we have this way, and this will take in a lambda block. Sorry, this block, this is lambda, and this will return generic type T. Then the whole body too should return T. This can be equated to with context, right? With the context we want to use is input output. This. Then from here we can simply call what our block function, because we are just wrapping it, right? Good. But then you remember that with context it is just wrapping using a different coroutine context, but then we need this transaction. So there's a function that will give us these two functions, which is new suspended transaction. If you check the documentation for this, let's check the documentation for this, right? You can see that we are using the coroutine context, which is passing, but then this is an extension of transaction. The body will be an extension of transaction, and this is what we want. So we'll go back to our query that we've created here. The whole of this will then be in query, our function query, yes, which is this. I prefer to have it without this. Good. Then you drop your query here, but instead of having return, can we just make it a single line expression. Yes, this. Good, this is fine. So we use this to get all our users from database. Then next, we want to get a particular user using the ID. For this, we're going to use an extension function on this too, but don't forget the query, right? This function, it has to be in query. You can have return. Now let's write the query first. Then for this, we have user table dot select. You are selecting all with a where clause for this. You see where the ID, user.id, they will call an infix function equal user ID, right? Then for this, we can simply map. Maybe let's map using reference to this. Then you get single or null, right? So simply equate this. Instead of having return, just simply equate this and make it a single line expression. So this is fine, right? We are getting all columns from our database with this condition, with this where clause, this equal to this. Then we are mapping directly to our function here. They were getting single or not because this is returning a nullable. Good. Then to save, again, we have query here. We call insert a static method or an extension function on user table. This is to Java, right? Then the first thing we want to do here is to save our ID, and for this we have ID, right? ID will be coming from the user model.id. Then duplicate this for first name, last name, age. First name, last name, first name, last name, age. Then we have age here. This is an integer. All right, great. This is expecting us to return a Boolean value to be sure if this was inserted. So we can simply have dot inserted count if it's greater than 0, right? Then this we should be good with this. If you return this, I think we can have this approach here that has return instead of having a single line expression here, so you can compare. So this is fine. We are good here. We inserted, then check the inserted count to be sure that it's greater than 0. It means everything is fine at that point. Then for update, right, query user table, call the function, the extension function update. To update, we are going to update first name to be equal to user model dot first name. Duplicate this for last name and age. Then we have this as last name. We have last name here, then age here. Right, good. And this will give us an integer number of inserted rows. So we can simply say if this is greater than 0, it means we are good to go at this point. But then we need a condition for this. If not, this will update all our rows in our table, right? So we can add the condition here, have it this way, to have user dot id to be sure that we're updating just one user, which is user dot id here, right? And this is good. We have a condition there, fine. I prefer to use it, make this very expressive by using a single line expression approach, right? Format this. So you see, this will check this and check that rows are being inserted correctly. Then if it's greater than 0, we are good to go. Then to delete, we have query here. To delete, we call the extension function on user table. Delete, you can delete where with a condition, right? And we are deleting where user dot id infix function equal to user id. Yeah, can we report this? All right, great. And if you want to be sure it has been deleted, can we equate a value here called result? What do we have on result? On result, we can check result dot okay. So simply put, if this is greater than 0, single expression for here, and it will pick that because this will give us Boolean and it's expecting Boolean if this has been deleted successfully using this particular condition where the user ID is equals to user ID here. It means we don't have to call this. Just simply call ID. This is fine. Then how do we check if user exists? Query user, we can simply select a particular column instead of selecting all columns. So we want to select user.id, right? Where have a where condition there, where user table.id inference function equal, then we have user ID here. Can we select count? Yes, count. Now if count is greater than 0, then we are good to go. Return this just to compare with single line expression with this and this. So we are done with our repository layer. Let's test this by creating, or we already have a REST HTTP client file here. Okay, good. So, and we are binding to a particular port. The port we are using is C port 8080. So if we come here, let's try and get all users, but then we need to run our application and be sure everything is good to go. So we've only modify our repository implementation class to connect to the database and replace this with a real-time database code instead of having in-memory collection here. So the application is running. Let's give it some time to run. Okay, good. The application is running, binding on port 8080. Then if we go back to our HTTP file here, can we get all users? Localhost 8080, get all users. All right, get all users. You can see we have empty users here, which makes sense because our database is still empty. Let's insert one particular user, this particular user, Janti Adebowale. Insert this to create a new user. See, created successfully, and it returns the ID. So we should be able to check our database and be sure that we have user in our database. So select asterisk, which means select all from user table. So we'll call it users. Select, run a query. Okay, good. Now you see Janti Adebowale, which is age 29. Can we add a new user? Let me add another user from our HTTP file, client file. I want to add a new user, Nike Adebowale. This should be, let's say, 25. Run this. This is successful too with a different UUID. So let's come back to our query here and check, run this query. Yeah, we have 2 users here now, so everything is working fine. We are connecting directly to our database. It means if we have to rerun or restart this application, our users will still be there because it's stored in the database, not in memory anymore. We'll come back here. I've restarted the application. Let me try and get all users again. Get all users. Now you see we have Jante, which was the first user I created. Then we have Nike Adebowale. You can see we have 2 different IDs there. So this is fine. Let's try and delete one user. I want to delete this particular one. So we need the ID to delete. Copy this ID. Come back to this place. Where is delete? This is delete. To delete user, we need the ID. Drop delete. Run it. Now this has been deleted successfully. Message process, and your code is 200, which is okay HTTP. It means when we come back here, make query to the database, we are going to have just one user. Then let's test test updates, or to get a single user, the same approach. If we come back here, run this ID, copy it. Then can we get this user from the DB? To get a single user from the DB, which is get single user, drop the ID here, run this. Now, this is our single user from DB, which is the only user we have. Then we want to update this user. To update this user, we need this ID here. Then we'll change the first name to Nike Adebowale, then age to be 25. Now run this. Now see, this has been updated successfully, processed successfully, right, with 200. The same ID, right, but the name is not Nike Adebowale. If we check our database, make this query to database, we have Nike Adebowale. So you see everything is fine. Now we are connecting our Ktor application to our database, which is Postgres. Now, if you want to change your database to maybe MySQL or any relational database, Oracle, right, you don't need to edit your code. All you need to do is to connect using the database credentials here, changing the URL and maybe the username and password, right? So it's just this connect you need to work with. Your code will still run perfectly well on different database, any other relational database, right? So this is good. Thank you for watching this video. Have a good day. See you some other time.